Look up right now. Whatever's above you, clouds, ceiling, open sky, picture the moon hanging there. Familiar, harmless. A pale little disk you've seen 10,000 times and never once feared. Now take it away. And in its place, put Jupiter. Not a bigger moon. Not a fun what if for a science class. The actual planet. A gas giant that could swallow more than 1,300 Earths parked at the exact spot where the moon sits tonight, 240,000 miles from your window. For about the first 3 seconds, it would be the most beautiful thing any human has ever seen. And then it would start killing you. Let's slow this down, because the way it kills you is stranger and more violent than any picture you could dream up. First, the view. Forget that tidy little moon that fits under your thumb. Jupiter at this distance would stretch across a huge slice of the sky, wider than your arm can span, wider than any window can frame. You wouldn't see a planet. You'd see bands. Rivers of cream and rust and burnt orange, each one a storm bigger than our entire world, all of them sliding sideways as the giant turns. And somewhere in that churning wall of cloud, the great red spot would rotate into view. A storm that has been raging for centuries. A storm so large you could drop the Earth into it and lose it completely. From down here, it wouldn't look like weather. It would look like an eye. A vast, unblinking, bloodshot eye turning slowly to face the planet it's about to erase. That's the postcard. Enjoy it. Because the physics underneath that postcard has already pulled the trigger. Here's the thing almost nobody thinks about. The moon doesn't just sit there. It's moving, racing sideways around us at roughly a kilometer every second. That sideways speed is the only reason it stays in orbit instead of falling on our heads. It's constantly falling toward Earth and constantly missing. But in our scenario, we didn't fling Jupiter into orbit. We placed it, dropped it there, still, with no sideways motion at all. And Jupiter is not some quiet neighbor. It carries 318 times the mass of the Earth. So the instant it appears, one rule takes over, and it's the oldest rule there is. What goes up must come down. And so must whatever has no reason to stay up. With no orbital speed to save it, our planet stops being a planet. It becomes a brick. A falling brick, 318 times lighter than the thing pulling on it, dropped from 240,000 miles up. From the moment Jupiter arrives, the Earth begins to fall toward it. And it will not stop. You've got one long fall ahead, not a few minutes, not something over in an hour, but nowhere near as long as you'd hope. Let's live through it. Stretch by stretch. At the very start, your body figures out something is deeply wrong, before your mind does. Gravity, the force you've trusted your whole life to be steady and boring, stops being steady. Because Jupiter is so massive and so close, the side of Earth facing it gets yanked far harder than the side facing away. Our planet doesn't get pulled as a single piece. It gets stretched. The rock beneath your feet, which you've always treated as the definition of solid, starts to flex like warm clay. The whole Earth begins to deform into the shape of an egg, its long end pointed straight at the giant. Solid ground does not enjoy being stretched. Every fault line on the planet lets go at once. Earthquakes past magnitude 10, stronger than anything in recorded history, tear the continents open. Every volcano that has ever existed, and plenty that never did, erupts together. And the oceans? Water goes where it's pulled. The tides, a few gentle feet, twice a day, become something with no name. The seas rise into walls miles high and march across the drowned land, chasing that giant eye across the sky. Coastlines don't flood, they cease to exist. That's just the opening stretch. And here's the cruelest part. The disaster is only warming up, and the Earth is falling faster every second. Now, if the gravity is slow torture, the radiation is the quiet execution that was over before it started. Jupiter doesn't just have a magnetic field. It has a monster, a magnetic field so enormous that if you could see it from Earth, it would look bigger than the Sunday. And that field does something horrifying. It scoops up charged particles from space and whips them into belts of radiation that would cook anything that dares come close. How close? Well, one of Jupiter's own moons orbits at roughly the distance we just placed the Earth. And in that zone, the radiation is measured in tens of thousands of sieverts a day. Let me make that number mean something, because a sievert is just noise until you feel it. The dose that will kill a healthy human being, reliably, no survivors, is about 4 to 5 sieverts. Not thousands. 4 to 5. That's the wall between you're sick and you're gone. At the moon's distance from Jupiter, you're absorbing tens of thousands of sieverts every single day. Thousands of lethal doses, over and over, before lunch. We've sent robots near this place. NASA's probes had to be wrapped in armor and flung on wild looping paths just to dart through the worst of it and survive. They were engineered for it, shielded for it, and they still had to run. The Earth would have no such luck. The moment Jupiter appears, that radiation floods over us. Every satellite dies instantly. Every power grid on the planet surges and fries. The lights go out everywhere, at once, forever. And at the same time, the same death, just a little slower, the giant's field starts peeling our atmosphere away, boiling it off into space, sterilizing the surface long before the surface finishes its fall. So while you're watching those beautiful cloud bands turn and feeling the ground shudder, you are already sitting inside a cosmic frying pan. You just can't see the flame. Now back to the fall, because we still have the worst to go. Somewhere around the midpoint of the plunge, the Earth has dropped most of the way down. Jupiter no longer hangs in the sky. It fills the sky. There is no up anymore. There's just the giant, a ceiling of storms swallowing everything from horizon to horizon. And here we reach a line drawn in the math of the universe itself. A line called the Roche limit. The idea is simple and merciless. As you fall towards something this massive, that stretching force, the one turning Earth into an egg, keeps getting stronger. And there's a distance where it wins. A distance where the giant is pulling on the near side of your planet harder than your planet can hold itself together. For the Earth falling into Jupiter, that line sits around 50,000 miles out. Cross it, and the argument is over. The very gravity that shaped our world into a sphere, that held the mountains and the oceans and you to its surface for billions of years, that gravity loses. Jupiter's pull rips it apart faster than the Earth can resist. Our planet does not crash. It comes apart. In minutes, the ground, the crust, the oceans, the last shreds of atmosphere, all of it is torn into a long, glowing stream of shattered rock and molten debris, stretched out like a river of fire falling into the dark. You might hope those pieces form a ring, something beautiful left behind, a monument. They won't. Rings need orbital speed, and remember, we never had any. So the wreckage of the Earth just keeps doing the only thing it's ever done in this story. It falls. Near the end of the plunge, the last of it arrives. The pulverized remains of our world, every ocean, every city, every fossil, every fingerprint of the fact that we were ever here, plunge into Jupiter's endless hydrogen atmosphere. There's no ground to hit. Just deeper and deeper cloud, thicker and hotter, until the debris is crushed, dissolved, and mixed into the giant, like a spoonful of dust stirred into a storm. No crater, no scar, no headline in the giant's clouds the next morning. Jupiter has swallowed worlds before, and it wouldn't so much as flinch. So here's where we land. We started with a daydream, swapped the boring old moon for the most spectacular object in the solar system. And it turns out that daydream is one of the most efficient ways to end a planet that physics will allow. The truth is, you would never get to enjoy the view. You'd never even get to be afraid of it. Because a world close enough to see Jupiter that large is a world already falling, already burning, already dead in every way that matters. That gorgeous giant in the sky, with its rivers of cloud and its great red eye, it was never scenery. It was never a moon. From the first second it appeared, it was the thing pulling you down. And here's what I keep coming back to. We call the moon boring, but the thing that actually keeps us alive was never how big it is or how bright. It's the distance it keeps. It steadies our seasons, it pulls our tides gently, and it drifts a little farther away every year, asking nothing of us. Boring, maybe. But look up at it tonight and be honest. For a neighbor that size, boring is the most beautiful thing it could ever be.